Okay, so this is number 5 and 6 on the diagnostic test. Let's take a look at number 5. We have an expression here to simplify, and let's see what we have. So we have a long string, it looks like, of addition. Even though we have subtraction symbol here, what we're looking for subtraction would be a minus sign outside parentheses. We don't have that, so we're just go ahead and combine like terms. Now I see a lot of fraction operations here as well, so we're going to talk about how we simplify that without a calculator, because that's something you're going to need to know how to do. So let's start with understanding what standard form is. Standard form is when we have the exponents in descending order of powers. So you see how I'm starting with the x squared. A is just some number. Then the x, and then the constant, and the exponents go down from left to right. That's what we call standard form, and so that's what you always want to end up with. Okay, so I'm going to start with the x squareds first. So you may have seen somebody do this where we group all the x squareds together. Good. Now it doesn't matter if the x squared's in the top of a fraction or in the back of a fraction like that. They both mean the same thing. So just to simplify that, I'm actually going to go through and take out. And I'll do that one too. Pull out those fractions so that x over 2 becomes negative 1/2 x plus negative 3 minus x plus 1/8 x squared. You don't have to do this, but I just want to show the coefficients very clearly. Okay, so then where are our x squareds? Well, we've got the 1/4 and the 1/8, and we're going to add those together. And of course they have to have like denominators. So 1/4 is going to be 2/8, and then 2/8 plus 1/8 is 3/8. You only add the numerators. So that's going to be 3/8 x squared. You don't have to do all this side work here. If you can do that in your head, you can just combine and make that 3/8 x squared. Okay, so let's see what's next, the x's. Now before I talk about the x's, we have to talk about these parentheses. So remember I said you only have to worry about it when there's a minus sign in front of them. There's a plus sign, which means the parentheses are really just kind of there for show, and I don't have to worry about them that much. So I'm going to just rewrite everything without parentheses. Let's also talk about this plus minus thing. Minus is going to take over that, so whether I write the plus minus or just the minus, either one is okay. So I've combined these. I don't need to worry about that anymore. So let's see what we got here. Okay, so as far as the x's, I've got a plus 12 minus 1, which is 11, and 11 take away 1/2. So when I rename 11, that's 11 over 1, and since it's 1/2, I'm going to rename that multiplying both sides by 2, 22 over 2, and then take 22 halves, which of course has the value 11, subtract 1/2 from it, that's 21/2. Now your calculator is going to give you 10.5. You really don't want to start looking at decimals. We don't favor decimals at this level. So try to avoid them if you can. Okay, so 3/8 x, and then this becomes minus 21 halves x, and then the minus 3 doesn't have any friends, so there you go. This is the trinomial in standard form. Okay, notice I only added like terms. That means the same variables that have the same exponents. So the x squareds are a group, the x's are a group, and the constant, the plain numbers, are also a group, and those things don't mix. Okay, so let's go on to number 6. Number 6 is a very complex simplification problem, and it does actually have some minuses in front of parentheses. I see 2. So there's 1 here in front of that, and there's 1 here. So there is going to have to be some simplifying here. Now, the rule for when it's parentheses inside parentheses like that is that we start with the innermost. Okay, so the innermost parentheses is this one. There's nothing to simplify. So I move on to the next set, which are the rounded ones. Try to simplify something in there, and as you go down, you rewrite everything. So, I'm rewriting everything, not changing anything except what's in parentheses. So, now there's a plus sign outside of this one. Doesn't matter. So I'm just going to pretend they're not there, and I'm going to find like terms within those round parentheses. So that's x and 9x is 10x. And negative 4 take away 5 is negative 9, plus 2 is negative 7. Okay, so I'm here. Okay, now that the rounded parentheses are all simplified, 10x minus 7 cannot be simplified anymore. I'm going to move outward to the squiggly parentheses. And so I'm going to simplify everything in there. Now the problem with that is that there's a minus sign outside the parentheses, which means I'm going to have to use the rule for subtraction, which is to distribute that negative across every term inside. So I did that, minus 6x, and then x plus 5, minus 10x, negative times a negative is a plus 7, and then plus 2x. And when I distribute that minus sign, the parentheses disappear, I don't need them anymore, and now I'm going to continue to simplify what's inside the squiggly parentheses. Let's keep going. Rewrite everything else. Do not touch that 6x minus until we finish all the business inside. Okay, let's add. So x minus 10x is negative 9x, plus 2 is negative 7x, and then the 5 and the 7 is 12. It's important to use these rules starting with the innermost and work your way out, because you want to make sure that you are doing the appropriate number of sign changes that is required. Okay, so now let us just simplify this last piece. Again, there's a minus sign. It'll affect everything in the squiggle brackets. So bring down the 6x. Minus times a minus is plus 7x. And minus times a plus, minus 12. And 6 and 7 is 13x minus 12. And since I can't simplify any further, that's my final answer. And that concludes 5 and 6.